Welcome to our explainer. Today we're going on a bit of a journey connecting some of the biggest ideas in the universe with the way we think about our own economy. We're going to dig into this one beautiful idea that lies at the heart of both and explore why it might just be a total illusion.
You know, we're taught to love symmetry. It feels right, doesn't it? In physics, this idea of a perfectly symmetric universe in its earliest moments, it's just so elegant. And in economics, well, the concept of a market in perfect equilibrium, where supply and demand meet just so, that's the bedrock of the whole field. They're two of the most powerful ideas out there. But what if they're both built on the exact same mistake?
So, let's start right there. Let's explore the powerful pull of these ideas. Why are we so drawn to the concepts of symmetry and balance when we build our most fundamental theories? What's the big attraction?
It's really fascinating when you look at how both fields approach the world. Take Peter Higgs's theory, the one that explains why particles even have mass. It starts from this assumption of a perfect, symmetric world that somehow broke. And then you have Adam Smith's invisible hand, which does something very similar for markets. It assumes there's this natural state of balance. In both stories, the perfect version is the default setting, and the messy reality we actually live in is treated like some kind of problem that needs explaining.
And this, right here, is where our investigation really kicks off. What if we've been asking the wrong question this whole time? Instead of asking why things broke, maybe we should be asking why on earth we ever assumed they were perfectly whole in the first place. Let's open up our first case file.
All right, let's dive into case file number 1, the physics of the universe itself. We're going to look for clues inside one of the most famous ideas of the last century. You guessed it, the Higgs mechanism.
For the Higgs mechanism to work, it needs a very specific kind of setup for its energy field. People often visualize it as a Mexican hat. So imagine a ball perched right on that central peak. It's perfectly symmetric, sure, but it's also totally unstable. It's bound to roll down into the brim, right? That's the area of lowest energy. But here's the key. That specific hat shape, it doesn't just appear out of nowhere. It has to be put there, chosen for the theory to work.
And here it is. This is our smoking gun. In his groundbreaking paper, Peter Higgs writes, "Let us suppose." That's it. That's the moment. This isn't some law of nature he's describing. It's a condition he is imposing. He's choosing the starting line. It's the moment the theorist, the hunter searching for an explanation, becomes the hidden cause of what they're about to find.
So the really critical point is this. The breaking of symmetry isn't spontaneous at all. Not really. It's actually an engineered outcome. The physicist makes a very specific mathematical choice. That's step 1. That choice creates the very specific Mexican hat shape. That's step 2. And from that point on, well, the outcome is totally locked in. The ball has to roll off that peak. Symmetry breaking is now guaranteed.
So to wrap up our first case file, the so-called spontaneous symmetry breaking that gives particles their mass isn't some random act of nature. It's the direct result of an assumption, a choice, made by the theorist. The physicist carefully sets up all the dominoes and then calls their falling spontaneous.
Okay, so keep that idea of the physicist's hidden hand in your mind. Now let's open our second case file, the marketplace. We're going to see if we can find the exact same pattern, an outcome that's been manufactured but is disguised as something natural.
In economics, the most iconic metaphor has to be Marshall's scissors. And it's a beautiful picture, right? You've got these two blades, supply and demand, and they work together in perfect harmony. And right where they cross, you get a fair, natural equilibrium price. It all suggests a really fundamental, elegant symmetry.
But if you look a little closer, are those two blades really equal? Think about it. Demand? That's a natural force. It comes from inside of us. It's spontaneous. It's almost indestructible. But supply? Oh, supply is a whole different story. It's heavily constrained. It's shaped by all these external, man-made forces. Patents, copyrights, licensing laws, monopolies, you name it. One blade is basically free, and the other is in chains. They're not symmetric at all.
And this just nails the consequence, doesn't it? If one blade of the scissors is free and the other is controlled, then the price they come up with isn't some natural point of balance. No, it's a point of leverage. The source material calls it a negotiated ransom, which is just such a powerful way to put it. Those scissors, they were never a perfect pair to begin with.
So, what have we got? We've seen a hidden hand in physics and a broken pair of scissors in economics. The argument here is that this is absolutely not a coincidence. It actually reveals a single fundamental error in how we tend to think about the world.
Okay, this table really puts it all together. Just look at these parallels row by row. Both fields start with this false assumption of some natural balanced state. In both, you have a system designed by human hands. It doesn't matter if it's the math of the Higgs potential or the rules of an institutional framework. Then, an artificial constraint gets imposed, which ends up sacrificing some kind of freedom just to make the model work. And the real kicker is that last row. What we call the invisible hand or spontaneous breaking, it's actually just human decision-making dressed up to look like a law of nature.
So, you see the pattern now, right? It is literally the same story, just told in two different languages. We fall in love with a beautiful idea, a perfectly symmetric universe, a perfectly balanced market, and when reality doesn't match up, we don't question our beautiful idea. Oh no. Instead, we invent this incredibly complicated story, a breaking mechanism, to explain away the difference.
And all of this leads us to the final verdict. And it's a verdict that suggests a pretty radical new way of looking at not just physics and economics, but maybe reality itself.
For decades, some of the most brilliant minds in the world have been asking this exact question. How does symmetry break? But what if? What if that has been the wrong question all along?
The real question, the one that's way more fundamental and honestly way more revealing, is this. Why were we so attached to the idea of symmetry to begin with? What was it? Some aesthetic preference, some philosophical bias that made us project that perfect order onto a world that is, let's face it, pretty messy and asymmetric?
And that brings us right to the core idea, primordial asymmetry. The world isn't a broken version of some perfect original. The fundamental, ground state of reality is, and always was, asymmetry. It was never whole. It was never symmetric. The world was never there, in some imagined perfect past. It is only here, just as it is. Symmetry isn't a property of the world. It's an idea we project onto.
The source material leaves us with this pretty haunting thought. It personifies these abstract particles, the Goldstone bosons, suggesting that in both physics and economics, to make our elegant models work, some kind of essential freedom had to be consumed. Maybe the real takeaway here is that we should start questioning our most beautiful ideas and look a little closer for the hidden costs and the silent sacrifices they demand from us.